Hi there, you're welcome to my YouTube channel, NN Fabian Chemistry. If you're new to my channel, make sure you subscribe and turn on the notification button so each time I upload a new video, you will be notified. And do well too to check out the previous videos I have done. So today we shall be learning how to calculate number of moles and number of particles. Calculating number of moles and number of particles. Actually, this is a challenging topic to most students out there. But I believe if you go with me through this video, you will find it pretty simple. To begin with, in ordinary life, items are counted using a named collection of them or counting units. For example, farmers count eggs in dozen. So a dozen egg will refer to 12 eggs. Shopkeepers sell sheets of papers in reams. A ream of paper contains 500 papers. So if we talk of 12 of a dozen, I beg your pardon, we are referring to 12 things. If we talk of a ream of paper, how many papers are we talking about? We are talking about 500 papers. Now, elementary chemical particles are very tiny. Chemists, therefore, for convenience reasons, count them by weighing a collection of them. So this counting unit in chemistry is what is known as the mole. The mole. That's the counting unit in chemistry. Now, the number of carbon atoms in exactly 12 grams of carbon-12 isotope is chosen as the standard. So, what is the mole? Simply put, the mole is a unit of measurement of the amount of a substance. Let's take a look at this. The mole of a substance is the amount of the substance that contains the same number of elementary particles, that is, these particles could be atoms, ions, or molecules, as there are atoms in exactly 12 grams of carbon-12 isotope. Remember a while ago we said we are using the carbon-12 isotope as the standard against which the units of other substances are measured. You should note that the symbol for the mole is the mole, but spelled this way. The scientist Avogadro did some research and found out the number of particles in a mole of a substance, and that is often referred to as the Avogadro number or the Avogadro constant. So, according to what Avogadro discovered, 1 mole of every substance contains this number of particles of that substance. What does that mean? Let's take a look at this. From here, therefore, we can see 1 mole of hydrogen atoms contains 6.02 times 10 exponent 23 hydrogen atoms. 1 mole of oxygen molecules contains the same number of particles. You can see 6.02 times 10 exponent 23 oxygen molecules. 1 mole of sodium ions contains 6.02 times 10 exponent 23 sodium ions. So 1 mole of every substance contains this number of particles, and this is often referred to as the Avogadro number or Avogadro constant. So how can we calculate the amount of a substance? Let's take a look at this formula. Here we have number of mole is equal to the mass of the substance in gram divided by the molar mass of the substance in gram per mole. And here we have a triangle that helps us remember the formula. So if we want to calculate moles, what we simply do, we cover moles like this. If we cover moles, what do we see? We can see mass divided by molar mass. There are situations where we could be given the number of moles and we have to calculate the mass. So if we have the number of moles and we want to calculate the mass, what we simply do is that we cover mass. What do we see? So mass will be equal to moles times molar mass. So this triangle makes it way easier to memorize the formula for calculating number of moles. We've used a name here, molar mass. We've used a name here, molar mass. What do we mean by molar mass? The symbol for molar mass is uppercase M. So what is molar mass? Let's look at this. The molar mass of a substance is the mass of 1 mole of that substance. What? The molar mass of a substance is the mass of 1 mole of that substance. So the molar mass of an element, you should note that, is the relative atomic mass of the element expressed in grams. For example, sodium. The element sodium, if you look it up on the periodic table, the relative atomic mass for sodium is 23. So the molar mass of sodium is, sodium has a molar mass of 23 grams per mole. That is the molar mass of sodium. The molar mass of a compound is equally the relative molecular mass of the compound expressed in grams. Let's take, for example, the compound carbon dioxide. We have carbon dioxide. Carbon dioxide, 1 mole of carbon dioxide has a mass of 44 grams. So the molar mass of carbon dioxide is 44 grams per mole. So now that we understand what molar mass is, let's go ahead now and solve some examples of problems involving number of moles. So let's look at example 1. Calculate the number of moles of carbon in 0.3 grams of carbon-12. So that's it. Remember here we've been given the mass. That's the mass, 0.3 grams. And the element here is carbon-12. If you look it up on the periodic table, let's get the mass of carbon. This is it. That's carbon. So we can see carbon has a mass of 12 grams. So the molar mass of carbon is 12 grams per mole. So let's go back to the question. We know that number of moles, which we can depict by small n, is equal to the given mass divided by the molar mass. The given mass in the question is 0.3 grams. So we have 0.3 grams divided by the molar mass for carbon is 12 grams per mole. So what does this give us? We now have 0.025 mole. Remember the unit for mole is mol, like this, mol. So that's it. Pretty simple, right? Mass divided by molar mass. Let's look at the second example. So we want to calculate the number of moles of chlorine in 7.1 grams of chlorine gas. Now take note, in the chlorine molecule we have 2 chlorine atoms. In the chlorine molecule we have 2 chlorine atoms. So let's get the mass of 1 atom of chlorine. Go to the periodic table. Here we have chlorine. Okay. Here we have chlorine. So we can see that chlorine has a mass of 35.5. So the molar mass of a chlorine molecule is 71 grams per mole. Remember, we have 35.5 times 2 because we have 2 atoms here, and that gives us 71. So the number of moles then, let's have it. Number of mole is equal to the given mass. This is the given mass in the question, 7.1 grams. 7.1 divided by 71 gram per mole. what do we have? We have 0.1 mole. So that's it. Pretty simple, right? Let's look at the next. We have sodium carbonate. So we want to calculate the number of moles of sodium carbonate in 5.3 grams of the salt. How do we do it? The first thing we need to do here is to calculate the molar mass of sodium carbonate. Now, if you have difficulties calculating molar mass, make sure you check out the video I did on calculating relative formula masses of compounds. So if we calculate the relative formula mass of sodium carbonate, we have this. So over here we have molar mass of sodium carbonate. We have 2 atoms of sodium. Sodium has a relative atomic mass of 23, plus we have 1 atom of carbon. So we have 1 times 12. 12 is the relative atomic mass for carbon. And oxygen, we have 3 atoms of oxygen. 3 times 16, the relative atomic mass of oxygen. That gives us 106 grams per mole. That is the molar mass of sodium carbonate. Now, we want to calculate the number of moles. Remember, we have the mass. The given mass is 5.3 grams. So the number of moles is equal to, we have 5.3 divided by 106. What does that give us? We have 0.05 mole. That's it. So let's look at the last example. Calculate the mass of 1.3 moles of glucose. We have the formula of glucose. Now take note, guys, here we've been given the number of moles. And what are we calculating? We want to calculate mass. Let's take a look at the triangle again. Here we want to calculate mass. So mass will be equal to number of moles times the molar mass. Okay? Now, if ever you forget the triangle, you can still derive it by looking at the formula. For example, we know that number of mole is equal to given mass divided by molar mass. So, if you want to calculate mass, what we simply have to do here is to cross multiply. So, mass is equal to moles times molar mass, as simple as that. So let's get the molar mass for glucose. If the molar mass for glucose, that is C6H12O6, is 180. Like I said, if you have difficulties calculating relative formula masses or molar masses, do well to check out the video. I'll attach the description or the link in the description below. So glucose has a molar mass of 180 grams per mole. So we want to calculate the mass therefore. So mass will be equal to moles, that is 1.3 multiplied by 180. What does that give us? 234 grams. As simple as that. Okay, so with these examples we've done, try these exercises. Before you try the exercises, let me show you another way of solving this problem. Let's take a look once more at this. Remember we said that the molar mass of an element is the relative atomic mass of the element expressed in grams, and the molar mass of a compound is the relative molecular mass of the compound expressed in grams. So let's make use of this to solve the examples we just did. Okay, the first question, question A, says we should calculate the number of moles of carbon in 0.3 grams of carbon-12. So how can we do that using another method? Let's see. Now we know that 1 mole of carbon-12 contains 12 grams of carbon-12. So X mole of carbon 12 will contain 0.3 grams of carbon 12. So X, then we know we have to cross multiply. We multiply this 2 and we multiply the other 2 and we divide. So X now gives us 1 multiplied by 0.3 divided by 12, and this gives us 0.025 mole. You see, we arrive at the same answer. Let's try the second one using this method. We should calculate the number of moles of chlorine in 7.1 grams of chlorine gas. Okay, let's see. Now we know that 1 mole of chlorine gas, 1 mole of chlorine gas, that is Cl2, has a mass of 71 grams. So 1 mole of chlorine gas has a mass of 71 grams of. So if that be the case, how many moles, that is X mole of chlorine gas, has a mass of 7.1 grams of. So X then is equal to, we have 1 multiplied by 7.1 divided by 71. And so what do we have? We have 0.1 mole. And lastly, let's look at this again. That's question C. Oh, okay. If we use the same method, we shall still solve it. Let's look at question D. Calculate the mass of 1.3 moles of glucose. So let's use this method. The mass of 1.3 moles of glucose. Now we know that 1 mole of glucose, 1 mole of glucose has a mass of 180 grams. So if that be the case, the 0.3, I want to believe it was 0.3, okay, 1.3 rather. So 1.3 mole of glucose has a mass of, we multiply these two and we divide by 1, it has a mass of 1.3 times 180. And what does that give us? 234 grams of glucose. So that's another method you could use to solve the problem, and you will arrive at the same answers. Now let's go to the exercises. Okay, so go ahead, pause the video and try these exercises. Calculate, we have the first case, the number of moles of lead nitrate in 2.0 grams of the salt. The B, the number of moles of sulfuric acid in 24.5 grams of sulfuric acid. And C, the mass of 0.5 mole of copper 2 sulfate. So pause the video and try these exercises. Okay, let's see what you've done. So let's begin with the first case. Calculate the number of moles of lead nitrate. The first thing we need to do is to calculate the molar mass of lead nitrate. Like I said, if you have difficulties doing that, make sure you check out the video I did on calculating relative formula masses. I have attached the link in the description below. So let's see if you calculate. We have here. Okay, good. So let's see, let's begin with A. So molar mass of lead nitrate. If you calculate it, you should have 331 gram per mole. Now, we've been given the mass in the question. The mass is 2.0 gram. So, number of mole equal to mass divided by molar mass. The mass being 2.0 gram divided by the molar mass, that is 331 gram per mole. So, what do we observe here? Gram cancels gram. We are left with mole. That's why the answer will be expressed in mole. So we now have, based on this, 0.006 moles of lead nitrate. Okay, so did you get it right? Let's move to the next. The number of moles of sulfuric acid. We've been given the mass. So here again, we need to calculate the molar mass of sulfuric acid. So B, the molar mass of sulfuric acid. If you do it, you should have 98 gram per mole. So number of moles, we were given the mass in the question, 24.5. So number of mole, which is given mass divided by molar mass, 24.5 divided by 98. What do we have? 0.25 mole. As simple as that. Let's look at the last question. I want to calculate the mass of 0.5 mole of copper 2 sulfate. Okay, so we saw it in the triangle that mass is equal to number of mole times molar mass. So let's begin by looking at the molar mass of copper 2 sulfate. Molar mass of copper 2 sulfate. If you calculate it, you would have 160 gram per mole. So we are given the mass, the mole in the question, 0.5 mole. So mass is equal to mole, 0.5 mole multiplied by the molar mass, that is 160 gram per mole. So if we look at it, mole cancels mole here, we are left with gram. So what does that give us? It gives us 80 grams of copper 2 sulfate. As simple as that. You could still try solving these exercises using the second method we used a while ago.